Okay, federation. So this is a pretty high-level description of federation, and some pointers to some of the next steps that we need to look at to make the federation protocol more useful. So I'm going to go through sort of the fairly quickly go through the structure of the protocol. I expect that some of you know it pretty well, and but let me go through it, and then anybody who's not particularly familiar with it might be better equipped to ask the right questions afterwards. So here I put up some of the diagrams from last year when we launched this. So with Google Wave, we sort of took an ambitious path. That we went out and said that Google Wave, we had something here that could replace email. I don't know exactly what how it looks today, but so we definitely wanted to look at communication in a try to build a new communication model that addressed many people use email today with hosted services like Hotmail and Gmail, and there's so much that you don't take advantage of. There's that we wanted to explore. So here that's apparent when you are when you use one service like Google Wave, right? Then we take advantage of that. Instead of there's being an immutable copy of the email message for each one who is on the email thread. There's a single shared and mutable object, and that's how we can get live typing and so on. And you can edit your message after you send it and so on. But to have a generally useful communication protocol, you would want federation. You would want your hosting service to be able to talk to others. So here are three services, and you should be able to share waves across organizations' boundaries. So when it comes to federation, Wave probably doesn't have as much new to offer as it does in a single hosted service. So we look very much at email and XMPP and other pre-existing federated protocols, and I think the federation protocol has a number of things in common and modeled about around some of the same concepts. You look up the other guys with DNS and so on. Indeed, the federation protocol runs on top of XMPP. So whereas with emails, you send these immutable emails to each other, what you want to achieve with Wave Federation is that you share these mutable objects. And so the way we model that is that it's the deltas that form waves are immutable. You mutate them by appending deltas to the delta history. And so if you look at you share waves across wave providers by sharing deltas much the same way as you do with email, and then you look everybody then composes this and then look at the resulting waves. That's how we share waves. Wow, that looks terrible. Okay, well, here are two wave providers. The message protocol is then about sharing deltas, and a lot of it is so we started with looking at a single service and the client-server protocol, and then we built a federation protocol that could tie things together. And the federation protocol is in some ways simpler than the client-server protocol because we just share deltas, and then we count on on the other end, there's a wave server that we're talking to, and it has the power to construct, to pull together these deltas and reconstruct the waves. So, as a matter of both sort of economy of expression and what was the other reason I wanted to give? I don't know. We just share deltas. We don't share snapshots of waves. So if on my wave there's a participant from another domain, and there's a edit to the wave, then the delta goes across. So suppose it's a delta that adds a participant from another domain, then just that delta goes across. It reaches that other domain, and it sees as a delta, and if it hasn't been part of that wave before, it can see that the version is not 0, and then it turns around and asks for the history of deltas up to that point, and so it can complete a contiguous delta history up to current. So what we exchange here is one wave server that hosts the wave broadcasts the deltas to the others. They can turn around and request history, and I already covered that in this morning's talk. So what I didn't cover was the security aspect of it. So when we launched Wave, just before we had a thorough security review, we had Leah Kirchner and Ben Laurie visit us in Sydney, and they looked at the whole Wave product, and then they also took a look at the Federation protocol. And they looked at it and said, hey, let's do better than email. 40 years has passed, and let's get some proper authentication into the protocol. Moreover, they identified that there's an extra attack vector in Wave that makes it particularly useful to have a proper authentication. So the thing is that so if you have here three web providers, love.com, evil.com, and peace.com, and you have somebody from love.com and peace.com that talk to each other. They might be talking to each other on a wave that's hosted in a third place. So there's sort of a wave provider in the middle thing going on here. And we wouldn't want that web provider in the middle to start spoofing messages, so that if I think I'm talking to somebody from somebody I trust from another domain, that I want to know that the message came from there, and so therefore they introduced then a security model here where all the messages are signed by the author's wave provider, and these signatures are propagated. So anything that somebody from love.com writes and is propagated to peace.com, peace.com will insist that if this is supposed to be coming from love.com, then it must be signed by love.com certificate. The wave server of the author of the delta. So this is authentication between the servers. So it's not the end user. So the assumption here is that each wave provider should be authenticating its users. So it's the job of the wave provider to identify that it's Soren at googlewave.com or love.com or whatever. I'm a user, and then the only thing that is authenticated across the Federation protocol is that it originates from the server that it's supposed to. I I use whatever secure authenticated connection there is between my client and my web provider. Then my web provider then takes my message and signs it with the here in this case it's acmeway.com with its certificate, and then it's verified throughout. So if you are hosting, let's see. So if you're right, so if you're love.com or peace.com in this scenario here, then you should sign the deltas you submit, and whatever you is broadcast to you from evil.com, you verify that the signatures are good. And it is the responsibility of whoever hosts the waylet, evil.com, to host copies of the certificates. Being the host of waylet means that all the signed deltas that are coming in from the participating domains, evil.com will want to verify the signatures on incoming messages. So it will retrieve the certificates that goes with them. So if peace.com sends a delta across, evil.com will ask for the certificate from peace.com, and then the contract must store that certificate in its certificate database, so that if immediately or a long time later some other party is on the waylet and wants to verify the history is properly signed all the way back, then they can go to evil.com and get a certificate. That is because who knows if it was peace.com, maybe that service is not running anymore. So you might not be able to find that certificate from the source anymore. Then another piece of the puzzle here is that the deltas that are signed is assigned together with a history hash, rolling hash over the server, the authoritative delta history of the wave. That severely limits how the wave provider in the middle can reorder messages. It's only up to basically up to what you can do with OT, meaning that the only when there's simultaneous messages being sent across can it choose to show them in one way or the other. And indeed, in that case, the participating parties, there is no sort of true ordering of the things. The transport, as I said, we use XMPP. So the Wave server talks in Wave in a box. The Wave server talks uses what's called component interface of the XMPP servers to connect to running XMPP server, and then that's all in the nitty gritty about discovery and so on to that these Wave servers sitting behind the different XMPP servers find each other. So this was my high-level description of federation. This afternoon there'll be a session where we'll talk about both client-server protocol and federation protocol, and we can drill into various points that we want to explore. But let me just so put up a slide here. This is from May this year from Google I/O. This was our list of federated providers at the time. So I don't know actually, how much of that is still true, and whether there are others on the list now. This includes various parties who demonstrated prototypes of products federating. Okay, some things that are missing from the protocol and that we should fix in order to make it robust enough that we can get real, mission critical communication running over the Federation protocol, is that here are a number of things that we were planning to do, but never got around to before Wave got cancelled. So one of the big things that we think is necessary is reliable delivery. So these messages are sent across XMPP and they make it or they don't make it. That's not good enough. So this morning I mentioned that how reliable messaging across the Wave bus is necessary to build reliable indexing. And I think it was our belief that it's a very similar story about Federation, and similar mechanisms can be used. So we did build reliable delivery messages across the Wave bus in the Google Wave production systems, and we were working on extending that to Federation until we stopped. Another thing I think is important to make Federation useful is to have support for groups. As Ian also mentioned today, this is an important aspect of a proper collaboration tool. We also had a notion of groups in Google Wave, and that was work in progress. We were had also identified as one of the areas that needed to be done better to enhance the usability of Wave, and we should definitely support that across Federation. So we had some designs for that. They're not so there are various internal notes that I'm happy to share the ideas we had about these things with anybody who's interested to talk about it here this week. Attachments. I think that we also had some designs for that. I think it's a relatively straightforward problem. I think we could find a protocol for this. It's not even certain whether you would need to change the Federation protocol as it stands, or whether you could build some conventions around that. If there's an attachment to a wave, that you within the wave, the documents in the wave, you could provide a description of the attachment, and it could maybe be served up by HTTPS or something like that.
So for attachments, are you talking about federating attachments, and that the attachments are transferred to the remote servers for caching, or in some sort of official manner, or just normalizing the way that attachments are stored and fetched on the host server?
I think the best solution would be to let the wave providers distribute it much like deltas and cache it for the users. Again, if you look at the case of an attachment started out with some wave provider that goes offline one day, then if others depend on that wave, it would be useful to that cache copies around. Then.
Trying to do live editing of the document necessarily.
But so when we talk about attachments and waves, they were embedded binary attachments. So I think if you want something like that, then you should, in the text of the wave or in some structured way, in the structured content of the wave, you should write a reference and share that. So this is about when you actually embed binary data in the immutable binary data.
It's just like with email, you can either send the actual attachment or you can just send a link to the live document.
Yeah.
at least we never considered the idea of hosting an attachment that's mutable in some way. Then something that came up because we've been around long enough when a year passed after the first Fed1 prototype was out there, our certs started expiring and nothing worked anymore. So we always knew that this would happen, and we should do something about it, but we didn't meet the deadline. I believe we should, in the spec, explain that expired certs should you should host the expired certs and host metadata about when they expire and are revoked, and so that when you see old messages from that were signed by certs that are expired today, that you can see that they were good at the time. Yeah, and then I brought from Sydney. I brought a laundry list of protocol bugs and omissions that we are aware of. That I don't think we filed issues for all of them. So if anybody's actually working on the Federation protocol, we should probably find an opportunity here this week and sit together and share our notes on what's broken in there. Then some other stuff. So in order to make a Federation more useful, as a sort of at the end user level. So when you use the wave panel on Acme Wave and Wavebang and so on, these blank avatars and so on indicate, that we should find out a way to get these prof avatar images across, and it would be good to have presence federated and so on. And so on the whole, be aware that the Federation protocol is very low level, deliberately so. In that diagram of concentric circles that Alex had at the end of his model talk, so the data that's so everything that the Wave server does, including Federation, is sort of at the lowest level. Its core is just shipping around these low-level operations and does operational transform, and it doesn't. The Wave server is not supposed to be knowing what it's talking about. What's the content of these things, and things, and in that general principle of trying to avoid that application level feature requirements seep into to the model to make causing us to create funny ops and stuff that causes a lot of churn and is difficult to check for all the correctness criteria that's necessary down at the core. Similar to something like profiles and presence, hopefully can be done by modeling things in waves or using other protocols. Presence, you could go either way. Define presence within waves and federate presence information, or say that it's better to use XMPP, other presence protocols, and provide guidelines for how a service should tie these things together. Something that held back us federating wave.google.com. We only ever federate the Soren, the Wave Sandbox developer instance. One of the things that held us back was that we were hosting all these, Google Apps for domain. All these different domains were hosted on the wave.google.com instance, and we couldn't sit around with private keys for all those domains. So the signing was unworkable. And this is exactly the same problem with something that is relevant to the XMPP community, who want to be able to host many domains on one XMPP server. And they are working on solutions for that. They have something called domain name assertions, where you, if you have your domain hosted by some hosting provider with lots of domains, then you write into your server records and DNS that you delegate to that other domain to sign on your behalf. And then the hosting server, we could just use a google.com certificate to sign all these many domains, and then you whoever wants to verify it would go to and see that each of those had in DNS had said that they were okay with that. So yeah, but whether we want to address that depends on whether we want to support these kinds of services. And then we tied this particular data type of these documents and the participant lists in ways together with Federation Protocol. It would be good to loosen that up, and I don't think there's anything particular. So the Federation Protocol ought to be able to work with any OT data type with the relevant properties. And just the last slide, I won't say much about this, but so there's some things one could that in principle sounds attractive. For instance, maybe you could share way faster if you just federate by federation, get a snapshot of a way rather than pull up a potentially very big history. I'm not sure exactly how that would work with the security model, so one could look at it, but it's not clear to me how to do it. Another thing is that wavelets are hosted by a specific domain. If that domain goes out of service and if evil.com shut down and Love and Peace want to keep talking on the wave, they can't. They just sit on these copies, and there's nothing to let them assume ownership of this. And again, I don't know how to do it, but peer-to-peer collaborative systems exist. Who knows? Maybe one could modify the Federation Protocol so that you don't have this rigidity. Another thing, again, I have no idea where to go with this and whether it's even useful, but is these email address style user IDs, is that an antiquated notion? These hardwired user domain association in the user IDs is, I don't know if that was the right way to go. We were not up for the task of solving that problem when we built the Federation Protocol, but I don't know what whether there are things to consider there, but in the long term that might be something to take a look at. Yeah, sorry I ran over. There'll be a session for discussion later today, but I'm happy to take some quick questions now.
Do you think using XMPP is, on the whole, a positive for Federation, or becoming an obstacle? And a greenfield revision might be a better way to.
Yeah. So it is a little bit awkward looking at how many hubs an operation runs through in and out of a wave server running through XMPP, and the encoding, binary encoding in stanzas in XMPP is an odd construction. Joseph's talk. There are many things you have to configure to get something working. It would be nice if in process more and more of the good stuff happened.
There's a lot of moving parts.
Right. Yes. So I was always asking myself that question. I think in many ways we successfully got some shortcuts to getting things off the ground this way. So in hindsight, I think we did the right thing, but I think it would be useful to look at and feasible to have multiple transports that you can do, just like you can have multiple client-server protocols for, running against a wave server. Then we could have multiple transports for Federation.
Yes. Okay. Private replies do the reverse anchor thing, and somebody had mentioned the idea of having a protocol or a service on sort of the authoritative federated server which would do the time warp transformation for you, or help with that. Do you have any thought about that?
Yeah, the same thought occurred to me that I think that would be a same thing to do. I think it would fit in nicely with the protocol, that it wouldn't violate any of the principles in there. So it would specifically save you from transferring all that data if you just want to transform that anchor.
Yeah.
So it's not entirely clear to me whether you would want, in all relevant cases, you would want that data anyway. So you. Okay. Again, apologies for running over, but Scott, there you are. Please take it away.